Mean is a measure of central tendency. But central tendency is a subjective, intuitive concept, while mean has a precise mathematical definition. It is quite difficult, if not impossible, to come up with a mathematical definition that fully captures human intuition. Mean is no exception. Before you use mean to measure central tendency, it is important that you know what aspects of the intuition are captured by mean and what are not. Suppose a typical height of adult females in a certain community is 5.5 feet. What should be a typical height in inches? Intuition tells us to just convert this 5.5 feet to inches to get 66 inches. This is intuitive. Is this really true for the mathematical formula of mean? If the mean of some heights expressed in feet is 5.5, then will the mean of the same heights expressed in inches be 66? Well, yes, as may be easily seen from the formula. The common multiplier 12 just can be taken out of this sum, and so we get 12 times x bar. Indeed, we can have this formula which you can prove similarly. Mean of a times x1 plus b, etc. a of xn plus b is just a of x bar plus b. Here the mathematics goes hand in hand with intuition. Now let's see where things can go wrong. Consider these squares. What is the typical side length of these squares? What is the typical area of these squares? Intuition says that if L is an answer to the first question, then L square should be an answer to the second. Let's see if the arithmetic mean formula conforms to this intuition. Mean of the lengths is this 3.5. But the mean of the areas is 13.5, which is not square of 3.5. Indeed, this is not just for squaring. If you take any transformation of the values other than the simple ax plus b type, then the mean will not transform in the same way. Suppose we have some numbers x1 to xn and we compute their mean, and if I transform all these numbers by some transformations which I denote by the letter f, then how will these things be connected? Our natural intuition is to say that this will be equal to apply the same transform to the mean. So you first apply the transform, then you compute the mean, or you first compute mean and then you apply the transform. Our natural intuition seems to indicate that these things should be the same. But I am going to convince you using a picture that this is going to hold only when f, this transform f, is of the form ax plus b, in other words, when the graph is a straight line. Suppose that I show this on a piece of graph paper. So this is my variable x and this is the transform variable, and I take just two values of x, x1 and x2. Then the mean of these two will be this center point. Now this transformation may be considered as a graph. So suppose my transformation is like this. So what is the transform value of x1? This will be this, which is f of x1. Similarly, this will be f of x2. Now when I compute the average value here and I compute the average value here, what will happen? The average value is like this, but if I compute average value of the mean, I will get only this. So I am not attaining this height. So the If I first compute average value and then apply my transformation f, I will reach only this height. Whereas if I first compute f of x1 and f of x2 and then compute average, then I will reach that height. Thus, in this case, whether I apply the transformation before or after computing average, that gives me different answers. Now, suppose I want to come up with that shape of the curve for which it should not matter. That is, whether I apply the transformation first or I take average first, I should get the same value. Which means, if I take the center point here and then I take the average, I should get exactly this value. It is the midpoint along the y-axis as well as the midpoint along the x-axis. So I know this point is on my curve, I know this point is on my curve, and this point must also be on my curve. Clearly they form a straight line. In my picture it doesn't look like a straight line, but they should be just like a straight line. Now again, if I consider these two values, then their average will land here and the average of these two will land here. So if I compute average of these two and then apply the transformation, I should get the average of these two values. So the point must be here. Similarly, the point in between should get to this point. In other words, I am actually getting the straight line joining these 2 points. Thus, we see that if I always insist on the fact that transformation applied before average or after average should give me the same result, then the graph must be a straight line. In other words, it has to be of the form ax plus b. It is hard to live with this fact, but it is a fact nonetheless. If you feel unhappy with this, don't worry. The measure of central tendency that we shall discuss in the next video is free of this problem to a great extent.